Welcome back everybody to linuxacademy.com. My name is Terry, and in today's video we're going to continue our exploration of Nginx, the web server. So over the course of the past 18 or 20 videos, we've taken a good long look at the Nginx web server. We've looked at the configuration, we've built multiple web servers, we've used it as a proxy, we've used it as a load balancer, we've taken a look at optimizing the configuration and how to manage SSL certificates as well as standard vhosts and redirects. When it was appropriate, we've looked at and contrasted the Nginx web server with Apache, since Apache is the most ubiquitous web server in use on the internet at this time. So we want to talk a little bit about conclusions. And the conclusions that we're going to talk about here are just basic conclusions that we've discussed throughout the course of our video series. So let's go ahead and get started. So why would we use Nginx? Well, I think as we've discovered throughout the course of our discussions, scalability and performance would be paramount for reasons to use Nginx versus Apache. We can talk about the 10,000 concurrent connections per second that large-scale Nginx boxes have been able to support, whether it was in large CMSs like Drupal or PressFlow or WordPress. We can also talk about the asynchronous master processing, a single process that's responsible for managing threads underneath of it on a connection-by-connection basis. We could also talk about the minimized data copies in memory. Nginx is extremely efficient in how it manages sessions in memory. In fact, one of the primary ways that it minimizes those data copies is, for example, even 10,000 inactive HTTP keep alive connections in memory only takes 2.5 megabytes. 2.5 megabytes of memory is used to support 10,000 keep alive connections. Now they may be inactive, but those cacheable connections, because they're all independent, they all contain different contents, only uses 2.5 megabytes of memory. It's extremely efficient in how it uses system resources, and it's very efficient in how it uses underlying memory and storage subsystems. Why else would we use Nginx? Well, features. It can be used as a proxy. So we can have multiple web servers or multiple services on the back end, and Apache can be proxied by Nginx if it's necessary, as can Tomcat or any other service that can receive a connection over any defined port. In fact, we can define everything in an upstream directive so that we can include that and proxy any connection that receives a TCP. Caching. We talked about how Nginx can function as a cacheable server so that we can use it not only to proxy web connections, but we could use it to cache connections. So it can be used as a caching proxy. Error code redirection. Inside of each of the vhosts, as well as the overall configuration, we can redirect common error responses, 404s, 503s, 504s, anything that has a specific web server response, we can completely customize and redirect to other locations in custom created pages. Nginx also has built-in video streaming support, so without the addition of any costly memory dedicated to a module, Nginx can support streaming of common web codecs. Custom log formats. So we configured not only the location of log formats on a domain or a system level basis inside of our Nginx configuration, we looked at how to customize how our access logs are written out so that they make the most sense for us. We can leave the overall configuration default in place, but on a domain basis, we can override that log format so that if we have development servers, if we have non-production servers that we need to do debugging on, we can turn on or up the logging so that it makes more sense in our situation. Log format rotation is extremely quick, and especially one of the primary items that is important for Nginx's overall performance in logging is that it offers buffered logging, so that logging is dumped to disk when it's available, when processing is available, rather than constantly waiting on I/O. Nginx also has support for the latest security protocols, which is important in an internet situation where we have things like the Heartbleed bug or the OpenSSL bug. Nginx is constantly updating its protocol support and has extremely good performance and security support for IPv6, which even Apache will admit that they're lagging behind on because of its adoption rate. Finally, Nginx has both an open source and an enterprise version, and that's important from an enterprise adoption perspective. Many times a company will be leery about adopting an open source solution, whether it's Apache or otherwise, because there's no official support model. With Nginx, you can use the full Nginx web server engine without any cost, or you can pay the organization that is responsible for the deployment and writing of the software. In addition, it does offer some additional features that enterprises can support. Lastly, Nginx offers competition, and competition fosters experimentation and innovation. Apache has ruled the roost for a really, really long time, and for good reason. Apache's performance has been stable as well as performant, but Nginx is really nipping at its heels. Competition in any industry, open source included, drives innovation, and each competitor pushes the other to do a greater and greater job. Apache's spending time optimizing their stack, and it'll be interesting to see what Nginx will do next to push the envelope even further. So this will conclude our video series on Nginx. We'd be interested in your feedback on how you're using Nginx in the enterprise or on your own. Specifically, if you have any requests for use cases that you might like to see here at Linux Academy, load testing or otherwise, feel free to leave us a comment. That's all there is to it. Thanks for joining us. My name is Terry for Linux Academy.